Hello physical science students, welcome to carbon chemistry number 4, the alkynes, or the alkenes. Some people, I like to call them the alkynes. And this is our third group of hydrocarbons. We've done the alkanes, the alkenes, and then the alkynes. Remembering the alkenes were our first group of unsaturated hydrocarbons in that they had the double bond. So you can probably guess what these guys might have. These guys have one triple bond between two carbon atoms, and that separates them from the other groups. And so here's a simple example of it. Ethine, also known by the old name of acetylene. So when you use a acetylene cutter or acetylene welding, that's what you're burning. And there's our triple bond. Each carbon again having its 4 bonds, and so only one hydrogen comes off. You can have a chain of 3 with a triple bond there. So this carbon has lots of hydrogens around it. This carbon has no hydrogens. But that's okay because it's got its 4 covalent bonds, and so it's happy. Now remember, we called these structural diagrams, where the dashes represent the covalent bonds, okay? And we're just trying to draw a rough representation of the bonding and the sort of shape of the molecule. Now their names for the alkynes end in "ine", and that shows us that there's a triple bond there. The general formula for them are CnHCn minus 2 in this case, because another pair of hydrogens are being lost to that double bond, or the triple bond now in this case. And they're also a homologous series, so they vary consistently and they show consistent chemical trends as the chain of carbons get longer and longer and longer. So they'll start off being gases with short chains at room temperature, and then as they get longer they become liquids at room temperature, and then solids at room temperature. They undergo combustion and addition reactions, which are the addition reactions is exactly the same as for the alkenes. Combustion reaction is exactly the same as the other two groups. So let's just a couple of examples which are interesting and just highlight their uses. Is acetylene. In the old days they used to use what was called carbide lamps or acetylene gas lamps, which burnt acetylene, and they were used in mines and various other operations, and it was a simple reaction between calcium carbide, CaC2, and water. And what you used to do is put the calcium carbide in this container here, and water used to drip onto it, and the gas was given off, and then that was burnt. And these were used in mines, but clearly there's a few hazards involved in that. And the least of which being that if you were a coal miner wearing this hat and you had methane being produced from the coal would blow up, or the methane would blow up. This is an example of a acetylene gas lamp on a motorbike, and this is a spotlight that used it, and this was the generator there. So fairly interesting. You can still see them around in second-hand shops and places, but no one uses them. This one was for a bush bike, I think. Now, cyclic, that's all you need to know about alkenes. So, cyclic hydrocarbons, we're just slipping this in here because this is a fairly short topic. These are carbons, or hydrocarbons, where the backbone, the chain of carbons, form a ring. And so they're called cyclic. They're also have a prefix to their name called cyclo, and that tells you that you're dealing with a cyclic hydrocarbon. And so hexane is a chain of 1, 2, 3, 4, 5, 6 hydrocarbons with single bonds. That's why the ane comes there. The hex tells us there's 6, then all these hydrogens. Now you can have cyclohexane where the carbons form a ring and there's 6 of them. So that's where the hex and the ane, there's no double bonds or triple bonds there, and then the cyclo tells us it's a ring. And these two guys have very different chemistry because they're different shapes. Now notice that these cyclic ones do not conform with the general formula that we have for each of the groups because they're cyclic. So you have to take that into consideration when you're talking about the alkanes, alkenes, and alkynes. And so you should be able to do these questions. Remember, the structural formula is just where you draw the structure of the molecule, but use lines to represent covalent bonds. So have a go at those, and you'll need to use your information sheet to get what those words, the prefixes, mean. And they would be the answers, something like that. And so the next video we're actually going to go into the seriousness of naming organic substances. That should be fun. Look forward to seeing you. Cheerio.